All right, we've got day 6 starting right now. One thing I want to mention is if you watch the day 5 video, the video ran, or the problem solution for part 2 ran about 2 minutes, even with Rayon. It is down to 7 seconds in the repo now. There's exactly one commit that did this. We basically just removed all of our allocation here, which brought the memory allocation down from a max of 32 gigs at any given time down to something like 18 kilobytes or something like that. And then we got rid of the progress bar. And apparently that takes up a good like 50 seconds of time extra. So something to keep in mind. Let's take a look at day 6. Today's day is wait for it. Okay, ferry on the island. We're signing up for something. We get a sheet of paper or puzzle input that lists the time allowed for each race and the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go further in each race than the current record holder. We need to break every record that we are told. Holding down a button charges a boat. Releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and the boats don't move until the button is released. So we need to determine how long to hold it and how far we're going. First race lasts 7 milliseconds. The record distance is 9 millimeters. Okay, so we have to match these two up to each other. Got it. Toy boat has a starting speed of 0 millimeters per millisecond. Okay. For each whole millisecond you spend at the beginning of the race, holding down the power button, the boat speed increases by 1 millimeter per millisecond. So because the first race lasts 7 milliseconds, you only have a couple options. Don't hold it or hold it for any number of seconds. There are 4 ways we could win. Determine the number of ways you could beat the record in each race. What do you get if you multiply these numbers together? Okay, so we need to take this. We will do just create day 6. Start with part 1, not part 2. Get rid of our to-do, drop this in, time and distance. Let's check our input first. Okay, so the input is just 1, 2, 3, 4 races. I hope that bodes well for us. 288 is what we need. So we're gonna write a parser again at the top. This is a fairly, I'll call it basic day compared to other parsing. And I think all we're gonna do here is have a tuple of vex of U32s. I think I'm gonna drop in num supreme here. I result nums off. I believe that I didn't specify num supreme here because we don't use it every day. I should add it to the actual template. So this would all work. And then nums. I already messed up my cargo tamil. I think that's a dash. Yeah, there we go. Technically, it would make more sense to do a tuple here. Okay, so I decided to go with a parse times function that did a separated pair with nums separated by a line ending. We skip the beginning. We skip everything up until we see the first number. Then we do a separated list of U32s separated by space, and we get 2 vex. Very small. I broke the nums out into a different function so that I could reuse it here. 3-line parser today, 4-line parser, whatever it is. So now we need times and distances, and we're going to have to operate on them together. So I think that we're going to do times.iter.zip distances. Then we'll map and we'll get time and distance. And this probably becomes a sum for a U32. I'll just make these zeros for now. So we've got 7 and 9, 15 and 40, and 30 and 200. And if we print line here, we'll get them on the same line. 7, 9, 15, 40, 30, 200 right up here in the left-hand side. So that's all good. So what we did here is we parsed out 2 vex, 1 from each line. We're taking advantage of nom supreme here to get a little bit more of an ergonomic API. People tend to like that, so I've started showing it off in videos. Once we have our 2 vex here, times and distances, we iter. We zip them together, which basically means we're going to iter over both of these at the same time. So we'll get the first item in the time with the first item in the distance, and that gives us the time and the distance that are supposed to be associated with each other. So the question is, this seems like another day like yesterday where we could brute force it and maybe that will work, and probably it won't in part 2. So let's do it naively to start. For every time, which is a U32, right? Let's into iter this too, because we're never going to touch that again. So we need what? 0 dot dot time. And these are all the options we have. So we can hold down for each of those. So we've got the button held time. And how do we calculate the speed? It's 1 for every millisecond. If we don't hold it at all, we don't move. I'm not going to special case that. We're just going to have that 1 millisecond. Then the boat will travel at a speed of 1 millisecond. So we don't need to do any math here. If it's 2, it's 2. It's 4, 3, yeah. So what we need to do here is button held time. Time minus button held time times button held time. I'm conflicted as to whether to call that speed or button held time. I guess that is just speed at this point, right? So we map over that. We get the speed. Time minus speed. That doesn't make sense when I write it. So time minus speed. will give us the time left. Time left times the speed gives us the distance the boat has gone. I guess we can filter map this. I was about to do a filter. So this can be this calculation still, right? Let my distance equals this. If my distance, let's do my distance. If I can spell distance today, my distance greater than, let's call this record distance in the variable up here. My distance greater than record distance, then some, and I guess let's keep around distance then. And this is count, right? So we want to count the number that we beat the distance in, and then we need to sum all those together, right? I guess technically this is going to be a U size, so we can sum into a U size like this. And I don't know that we're doing the right calculation here, so let's check. The number of ways you can beat the record multiplied together. Okay, so 4, 8, 9. That would give us 21 if added, but we can product here instead of U size, and we pass our test, hopefully. We failed a test because of the parser, so let's just test the parser here. Oh, you know what the problem is? Okay, we don't need to test the parser. I misread the error message. The issue here is that we don't have any input because we're benchmarking based on the input. So let's get our input, dump that in here. Clippy is telling me we don't need the intuitor here. That makes sense. Our test is passing right here. So we're gonna run day 6, part 1 in release, and we get the answer immediately. And as usual, we hope this is the right answer. Gold star, sick. Okay, and the race is about to start. You realize the piece of paper with race times and record distances is only very bad kerning. There's really only one race, so it's just one number. Now you have to figure out how many ways there are to win this single race. Race lasts for a long time, and the time we need to beat is big. So there's obviously a better way to do this, but let's just copy this into part 2. Grab this number, get rid of product here because we only need the count now. This is going to end up being a single number. So you go is not this. This is not really a separated list anymore per se. We'll do digit 1 here for a separated list. We could do a fold many, but I'm not going to do that. We're going to do a separated list. We're going to map over it. We're going to get a list.join with nothing. And this isn't going to be a vec of U32s. This is just going to be a U32. And these are going to be 2 U32s. And if this is working, then we still need to parse into a U32 here and expect a valid number. So we took what was a parser for a separated list of individual numbers, and we were told that that needs to represent a single number. So we just took a map over the digits that we had. We joined them together. We parsed that number, and now we have 2 numbers. So this is no longer a zip. I'm going to take this declaration and replace our original. Then I'm going to remove that and that. And this should be a thing that works for us. So part 2 passes. And really the only question is how long is this going to run for? Positive overflow. So we need U sizes here. That's scary. U64s. Let's make sure our tests still pass. Tests still pass. Let's run. That is suspiciously fast, but it's right. I don't trust that at all. After yesterday, I don't trust that at all. Okay, well, we're done. So let's do the how-to or the deep dive. Or I guess we can benchmark this. We want to benchmark day 6 and not overload our AV1 encoder today. So our day 6 bench will be this one. We've got 457 nanoseconds and 15 milliseconds. I'm going to call that okay for today. We can DAP profile part 1. We can DAP profile part 2. These are like 12 kilobytes. A kilobyte. So yeah, not really much to go over here performance-wise. We've got our parser. We've got a separated pair here. So a separated pair, that's 2 lines separated by a new line. We skip all of this and get right to these numbers here. In part 1, we use a separated list once we get to one of those numbers, and we do separation by space 1 for U32s. In part 2, U32 doesn't work, so we use U64, but it's the same thing, and we just map over this to make one number instead of many numbers. Then we take those 2 vecs, we iterate over them. Zip is the most interesting thing from today. Zip is a function on iterators that allows you to take 2 iterators and iterate over both of them at the same time. It is important to note that these should have the same length. So they should be both an iterator of 3 items or something like that, because you want to pair one number to one number. That gives you a tuple. So we get our time and our record distance. We iterate from 0 to time and we filter over that. We do the simple calculation to take every possible time we could have been holding the button down, which is exactly the same number as the speed. We calculate the time left in time minus speed, and we multiply the time left by the speed we're going. And then we check to see if the distance we've covered is greater than the record distance. If it is, then we return a sum. This filter map will use it. If it's a none, this filter map will discard it. We count any of the ones that are left, and that is the number we need to multiply together to get our result. Basically the same thing for part 2, same logic, we just parsed it differently, and we didn't do a product. So part 2 is the same as part 1. We brute forced it, it worked, 16 milliseconds or something like that. I'm happy with that. I'm gonna call it a day. Short one today. I'll catch you in the next one, I guess. Have a great rest of your night.